All right, let's go ahead and take a look at some more box plot comparisons. This time we're actually going to be looking at kind of two box plots and trying to figure out how to compare and contrast them. Okay, so we're comparing Collier and Hendry counties in Florida, and we're looking at their age distributions. Okay, so we know Florida is a big area for people to retire to because it's nice and warm down there. But that is not necessarily where everybody lives. So if you think about um, population, do you think the older people, the older generation, the retired people are going to live next to the beach, or do you think the younger people are going to live next to the beach? Which one of those do you think makes more sense? Okay. Well, let's take a look at where these counties actually are. So the purple county is Hendry County. You can see that's a little bit farther in from the coast. And then we have the green one, which is Collier County, and that is right on the coast. So obviously they have beachfront property. Okay, let's take a look at our data. So if we take a look at, and this is age down here at the bottom. If we take a look at Hendry County, we see the median age for Hendry County is 44. Okay, so that's mid range. And we see that 50% of the data is more than 44 years old and up to 109 years old. It's pretty old. Now let's take a look at our Collier County, so the beachfront property. Instead of having a median of 44, we see that Q3 is actually 43, which is pretty close, but only 25% of the data is between 43 and 108, where this one was 50% of the data. So from that, I can clearly see that more young people, because 75% of the data here, 1, 2, 3 sections, is less than 43 years old. So in Collier County, the green county, 75% of the people who live there are less than 43 years old. Okay. Only 25% is 43 and older. Versus the purple county, 50% of them are more than 44 or less than 44. So the older generation is living farther away from the coast. Okay. More people who are older than 43 are living away from the coast versus next to the coast. Okay, so let's see if we can figure this out. Okay. We have to figure out which one has the most people over 50, who has more kids in school. We can try to make those decisions. Okay. So, can we determine which has the most people over 50? We have no idea. We cannot determine this. Okay. We do not know how many people took the survey. However, we can figure out which is the biggest percentage over 50. Okay. The biggest percentage over 50. So 50 is right about here. If I draw that up, I'm going to say if this is 50%, I'm going to say that's about 45% of my data. And if this is 25, I'm going to say this is about 20. I'm going to say this section right here is about 5%. So which one of these has the largest percentage of people above 50? Hendry County definitely has the older population because it has 45% of its data. Okay. Who has more kids in school? Well, what do you think about that? Do we have a way to tell percentage or number wise how many kids are in school? No, but I can definitely kind of determine from the percentages where the younger generation, the majority of the younger generation is. Okay. I know that normally when you are in the 60s, you probably don't have children in school. Okay. But if I take a look at my median, would it be uncommon for people in their 40s or 30s or 20s to have children? No, it's pretty common for people that are under 40 to have children. So I can look at this and be like, oh well, this 50% of the data here, this one has 75% of the data. I can probably make a statement that Collier probably has more young people, more kids in school, because 75% of its data, of its people, are showing it to be less than 43 years old. Okay? That means that this next statement I can also make and say it's Collier, because the youngest population overall, this one's 108, but this one has more under 43. Okay, so 75% of its population is under 43. So that is a younger population. That median versus that Q3, that is kind of how we can see that. We can compare the Q3 and the median, and that kind of lets me know where that line is. Okay, so you want to kind of line up equivalent sections of the box plot, and you can kind of make determinations based on that data. Okay, let's take a look at some more of these. All right, this is box plot and whisker representing cost in dollars of 12 CDs. There's only one box plot here. Okay, so this is money, and we're buying 12 CDs. Okay, which cost is the upper quartile? Well, upper quartile is Q3 and our maximum. That's our UQR. Okay, so that is 26 and 29. So 29 minus 26 gives me a value of 3. Okay, gives me a value of 3. What is the range? Well, range, remember, that was our max minus our min. So maximum we said is 29. The minimum looks like, if I kind of line this up, that's a 7. 29 minus 27 is going to take me to a 22. What's the median? Well, the median is here in the middle. Remember, median means middle, and it looks like it's not quite 21, not quite 20. It's in the middle. So that would be 20.5 or $20.50. Okay, which cost represents the 100th percentile? So if I'm talking about 100%, that is the max. Okay, 100%, because 25, 25, 25, 25 right here, that means 100% of the data is behind me. This is the 100th% spot. Okay, so that value is a 29. How many CDs cost between $14.50 and $26? $14.50 is here. $26 is here. So I'm going from here to here. Can I actually tell them how many CDs? No, I cannot tell them the number. Okay, but I can tell them the percentage. That is one section from here to here. That is 25%. So I can tell them that 25% of the CDs are between those, but not how many. Okay, not a specific number. How many CDs cost less than $14.50? CDs less than $14.50. Again, we're not going to be able to tell them an exact number, but if I'm looking at less than $14.50, that means I'm starting here and I'm going less than, means I'm going to the left. That is one section. That's going to be 25% of my data is less than $14.50. Okay, here's another one. The box and whisker plot shows the ages of 36 players on the 2016-2017 Buffalo Sabres hockey team. We're talking about ages. And it wants to know the IQR, the interquartile range. So remember, that is the box. It's how big the box is. So it's Q3 minus Q1. Well, my box starts at 28 and it's going down to 22. So that box is 6. Okay, that box is 6. Has a distance of 6 ages in between the 22 and the 28. About what percent of the players are at least 25 years old? So remember, at least means greater than or equal to. So 25 years old, that's here in the center. So at least means greater than or equal to. So that is 2 sections. 1, 2. So what percentage is that? Yeah, that's 50%. 50% of my players are at least 50 or 25 years old. About how many players are no more than 28 years old? So that's less than or equal to. So that means I'm starting out at 28 and I'm going this direction. That's 1, 2, 3 sections. That is 75% of my data. Okay, 75% of my data is less than the 28. All right, that should kind of get you going on your box plots. Again, if you are struggling, make sure that you watch the videos in the red help folder on box plots. There's some good examples in there on interpreting too. Reach out to me if you have any questions, and we'll see you on the next day.